Section 4.8, Applications of Trig Functions. We're going to start these notes off by kind of reminding ourselves how to solve a right triangle. So in this first example, we have a right triangle. Angle A is 62.7 degrees, and side A is 8.4. We're going to solve this and round our lengths to 2 decimal places. The first thing I'm going to solve for is my one unknown angle, which is B. I know that angles A and B have to add up to 90, since angle C is 90, and all three angles should add to 180. So when we subtract angle A from 90 degrees, we get angle B to be 27.3 degrees. Next, we're going to pick either side C or side B to solve for. I'm going to solve for side B, and I'm going to use a tangent function. So we're going to have tangent of angle B equals opposite over adjacent, which is B over A. I can plug in angle B and side A, and in order to solve this equation, I'm just going to multiply 8.4 over to the left side and plug that in my calculator. I get side B to be approximately 4.34. Next, we're going to solve for side C, and I'm going to use, this time, sine of angle A equals opposite over hypotenuse, so side A over side C. We plug in what we know, and this time notice C is in the denominator, so I'm still going to have to multiply over my denominator, so I'm going to multiply C over to the left side. And then my last step when solving for C is just going to be to divide by sine of 62.7. And we get side C to be 9.45. These two trig functions that we used here weren't the ones that we had to use. We could have used different angles and different trig functions. So if you looked at this and you had something different set up, as long as you know two of your three variables here, two of your three unknowns, then you would be able to solve for the unknown that you have in the equation. Example 2, finding a side of a right triangle. From a point on level ground 80 feet from the base of the Eiffel Tower, so down at the base of my triangle I have 80 feet, the angle of elevation is 85.4 degrees. So remember, angle of elevation is where we're looking up at the top of something. So this is like looking up at the top of the Eiffel Tower. Approximate the height of the Eiffel Tower to the nearest foot. So since I want to know the side opposite of my angle, 85.4 degrees, and I already know the side that's adjacent to that angle, I'm going to use tangent. So we have tangent of our angle equals opposite, which is side A, over adjacent, which is 80 feet. In order to solve for this, I'm going to multiply my 80 to the other side, plug it in my calculator, and I get 994 feet. Example 3, finding an angle of a right triangle. A guy wire is 13.8 yards long and is attached from the ground, so point A, to a pole that's 6.7 yards above ground. So the right side that's labeled 6.7 yards is my pole. Find the angle to the nearest tenth of a degree that the wire makes with the ground. So we're trying to find angle A here. The two sides that we know are the opposite from angle A and the hypotenuse, so we're going to use sine. Our equation is sine of angle A equals 6.7 over 13.8. The way that we solve for angles is by using the inverse trig function. So I'm going to use sine inverse on the right side of my function to solve for A. We get 29 degrees for A. For example 4, we have a figure here, and it's asking us to find this side on the right that is labeled as X. First of all, I want you to notice that what we have is just two right triangles. So I'm going to use SOHCAHTOA trig functions to solve for the right piece of each of these triangles and then add it together to get x. So the first thing that I want to focus on solving for is this side right here. I'm going to call it y. So let's just focus in on this top triangle. And again, since it's a right triangle, we can use SOHCAHTOA. So my angle 20 degrees, I want to know the opposite side, and I already know the adjacent side. That means I'm going to use my tangent function. So we have tangent of our angle, tangent of 20, equals y over 100. To solve this equation, I'm just going to multiply 100 over to the left side. And we get y equals 36.4. Next, I'm going to focus in on this bottom triangle right here, which is also a right triangle. And we're going to solve for the other piece on the right side. We'll call that z. So I know that my angle 8 degrees. I want to know the opposite side, which is z. I also know the adjacent side, which is 100. So again, I'm going to be using tangent. So tangent of my angle equals z over 100. Multiply the 100 over. And we get z equals 14.1. Now, in the end, I wanted to know the length of x, so I'm just going to add those two answers together, and I get 50.5. Example 5 is the same idea. So I have two triangles going on. One of my triangles is this small green right triangle, and then the other triangle that I want to use is the entire thing. Again, this is also a right triangle. So we're going to start by finding this side right here. We'll call it y. So I'm looking at the big right triangle. So my angle that I know is 34 degrees. Across from the 34 degrees on the opposite side is 300. And I want to know my adjacent, which is y. So I'm going to use tangent. When I solve this equation, I get y equals 444.8. Next, I want to focus in on that small triangle and find the base. So this bit right here, we'll call it z. So I know my angle is 64 degrees. I know the opposite side, and I want to know adjacent. So I'm going to use tangent again. Going to have to multiply z over to the left side, and then divide by tangent of 64. And we get z equals 146.3. So in the end, I need to remember that I'm trying to solve for x. So I'm going to take my y value, 444.8, and subtract off my z value, 146.3. So x is just going to be y minus z.